Algebra, relational algebra is the way to access the data in the relational database model. So we start from the information and the conceptual modeling and relational database modeling. Then eventually we try to create a database and using the DBMS like the MySQL or the Oracle Database Management System. But to do that, we need to have the tool or languages. So instead of directly learn how to use the SQL, so we try to see what is the fundamental, kind of what is the grammar of the SQL languages. So to do that, Dr. E.F. Gould and his colleague proposed the relational algebra or relational calculus. So I explained what is algebra, what is calculus. So I will explain the relational calculus later, very briefly. But both of them are fine. Either of them is fine to learn the SQL, but the relational algebra is more useful and the efficient way to understand later how DBMS processed your submitted SQL. So eventually, the DBMS engine need to optimize your query. Your query is, I need this data. The problem is how to access the data. Sometimes think about when you the climb up top of the mountain, there are a bunch of different ways. One is nice trekking path. Sometimes you like to climb up to the rock, and sometimes you can use the kind of jump from the airplane. There are a bunch of different ways, but a DBMS engine would like to find the efficient way to access your data. At that time, relational algebra expression will be used. So it is better for you to understand what is a relational algebra. For future, when we talk about the query processing, query optimizer. So to do that, first we talk about the unary operation. So relational algebra, first you need to understand what is a relational algebra and what is a relational algebra expression. It's kind of the writing a sentence. So to do that, when you write a sentence before, so first your goal is to write an essay. So however, if you do not know any vocabulary or word, you cannot start to writing. So for such a vocabulary, we are going to see relational algebra, relational operation. So relational operation is like the plus, minus, subtract, and the multiplication, like the division. Okay, such an operation. So if you deal with only the one relation, it's called the unary operation. So first part of the relational algebra is a unary operation. Unary operation needs the one relation as an input. So one more time for your reminder, that any relational algebra operation, any relational algebra expression, input is a relation and also output is a relation. Is there any way to turn off? First I try to turn off this one. So the unary operation, any relational algebra operation is the input, is the relation, and then the output will be also relation. Because of this characteristic, we can combine output as another input. Eventually, this will be relational expression. So relational algebra expression is like the what? Sentence. You can build a sentence. So our goal is to create such a relational algebra expression by combining several operations. So first, you need to understand what kind of the operation we have, how to use it. So last class, we talked about several unary operations. So first unary operation is, anyone who remember? Sigma, selection. So this is called the selection. So main purpose of the selection is if we define the relation like the tabular style, table view. So we have a number of attributes, that is a relation. We have also number of data or tuple, that is also relation. So sometimes we are not access the relation by the tuple. by the data by providing one condition or sometimes a filtering. So such a condition will be the input is a relation of with the condition. So this is called the selection. So selection is called filtering operation. So most popular one. So I want to access this data whose the department number is 5. I want to access the data whose salary is bigger than the 30,000, like that. So condition will be provided. So this is a selection condition. The second operation is project. Okay? So because this is another definition of the relation, so we can access the data, not all attribute. Instead, I'd like to access only specific attribute, like that. So you can list the such an attribute for the relation. So this is called project the operation. Project is operation specify a number of attributes that you want to access. Then by combining these two, actually we can implement most of the SQL eventually. So for example, I want to access the data like this. So attribute 3, attribute 4, whose salary is bigger than 30. So you can combine these two to access a specific data and with the specific attribute. Also, there are two rename. So output of this relation, we need to provide the name. So we can use the arrow, left side arrow, and the new name. So this is the rename of the attribute. Not attribute, rename of relation. Also, there is another rename which is called the row, the RHO, the in Greek letter. So if you want to specify this is A3 is too general, so I'd like to use the FN, the LN as a kind of alias. So we can the rename of this is a rename of the attribute. So this is what we covered the last week. So it's a very basic, the unary operation. As you can see, input is one relation. Input is one relation, and this one is a relation rename, and this is a rename of the attribute of one relation. So we can rename such the specific attribute. So for example, keep in mind, or you can take a look at the handout, so company database. So we are going to use the company database. So somebody asked you, we already create a company database, relational database, the schema we have in our mind. So we wanna access, so we treat the first name and last name of employee who work for research department. So we'd like to create the relational algebra expression using the unary operation. So when you build the relational algebra expression, first thing, what is the most important part when you create the relational algebra expression? First, relation, source of data, where you can find the data. So what we want to do is the name of employee. So we need to access employee relation first. So we can get the first name, we can get the last name of employee who work for research department. Where can you find the research? This is the what? It's a department. You cannot find. Employee has the what? Only what? It's a DNO. It has the department number, but it doesn't have the department name. So we need to access department. So how can you access this data? So first, we'd like to access employee. And we'd like to access what? The research department. Okay? So find the selection department. And whose D name is research. Then this is what? Research DPT. Okay, this is a rename. Then the next thing is, so we from the research DPT, what we want to do is what? We need to find the DNO. So project DNO. I think that this one is not a good example right now. So I will use this one later. Because it needs a join operation, which we do not cover. Works for let's say that this one, the simple one. Okay, I'm sorry. So which we do not cover yet. So same thing. So first thing is we need to find source of data, relation. So at this time, the employee. Then check whether you can get all the data from employee. So first name, last name, and DNO, and salary. All of them are in employee table. So we can start the employee. Then select, apply the select. Select one. So DNO is equal to 5. And whose salary is bigger than 20K. So this is the output of employee. However, we need the first name and last name. Then this is the final result. So this is the relational algebra expression that we want. Okay? Somebody may ask, can I switch this one and this one? Yes. If we switch like this, no condition, we cannot find output of this project does not have DNO, does not have salary. You need to put. Then after you select, you need to project again. So it's not convenient. It's a duplicate. So at this time, it's not commutative. You cannot exchange the operation. Some of the operation you can exchange, sometimes not. So this one is the example of the unary operation. Okay, the next. Last time, when we talk about the relational model, when Dr. Yef could consider a new database model, what is the motivation? Why he need such a relational database model? It's a very large data. So when he has the very large data to be shared, so traditional approach like the network model, hierarchical database model, such a database model is not good enough to process such a very large data. So he considered the data as a group. His idea comes from mathematics set theory. So in set theory, so if you remind what you have learned in the middle school or the elementary school, when you learn the set theory, so you first learn about the A is 1, 2, 3, or B is the x bar x. X is a whole number, like that condition. Also, you learned about the operation A intersection. A the union. A minus. Okay, minus means belongs to A but not B. So we can because the relation comes from this. So we can adapt the same idea to the relational the model. So in relational model, so we have the binary operation. So binary operation means it needs as an input two relations. So two relations, so we can use the intersection, also the union, and the minus, and the what else? So for example, I'd like to give you the example of so A is A comma the B is a two element. The set B has 1, 2, 3. Have you ever heard about this one? It's a Cartesian product. So Cartesian product is another operation in the set theory. What is the output of A times B? Actually, it's not times. Product of B. A1, A2, A3, and the B1, B2, B3. So all combination of each element, right? So this is called the Cartesian product. So another binary operation used in the relational algebra expression is the Cartesian product. So we can use the exactly same operation in the relational operation. Let's see the example. So here, what is the, in this case, the student has a first name and last name and this one, and the instructor is like this. If we union, so this the student union instructor relation will have this one plus this. So at the time, output will be how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. It should supposed to be 12. The tuple. But when you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's only 10.
Common name.
So why?
Common name.
Common name, as we discussed last time, that any all relational algebra expression and operation, their output is also relation. In mind, the relation should be unique. It's the primary key. So all duplicate data, common information will be deleted. So in this case, the Ramesh, not Ramesh, Susan Niao. Susan Niao is common, so it will be removed, and also who else? Ramesh is also here and here, so it's only one time. Okay, automatically removed. So output is like this one. One more question. When you see the student attribute, it's Fn, Ln. This one is Fn, Ln. Can it be operated? Can we use the union or intersection minus or not? Yes. When we check when we operate the set operation, union, the intersection, minus, and Cartesian product, they don't have to be the same attribute name. Instead, more important thing is
Value same.
value. In other words,
Number of.
where does the value come from? Domain. So domain should be same. In other words, it's a type comparable. However, if you have another attribute here, can you operate this one? No. The number of attributes should be the same, and also each attribute should be type comparable. Okay? It doesn't have to be the exact name, but should be from the same domain, same value. So that is the only one you need to check. So when we operate this, output is like that. Okay, so this one is the typo. This one should be intersection, right? So in case of intersection, it's like that. And the minus is belongs to student, not the instructor. And this one is belongs to instructor, but not student. So we can use later. What about the SQL? Relational database. Do they support this one? Yes. It's frequently used in the SQL. Okay. So we had set operation union, intersection, difference, and so on. Then the next one, keep in mind, this is type comparable. Okay? So in other words, it's domain. This is just in advance. Later, when people implement the SQL based on the relational algebra, domain is not easy to implement. Think about the domain. What is the definition of a domain? All possible values. So you need to list up, for example, if somebody define the name domain, how many possible names? Almost infinity. So billions of the names are possible. So can you keep the all possible names in a database, in a computer system? Physically, it's not possible. Okay? So to address that problem, the people who developed the DBMS database system, instead of using domain, they use data type. So think about what is the type. Definition of type in computer science. Type is kind of standardization. So when we talk about the entity type, relationship type, entity type means, do you remember? Entity, 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 then we can create the student entity type, right? It's kind of a common, standardized. In database management system software, instead of using the domain, we standardize as a data type, like the character, number, and character 10 byte, number 10 digit, like that. So later we throw away domain, instead we use data type. So eventually, so that is the reason when we operate such a binary operation, we consider type comparability. Type comparable. Okay? So this is the type comparable. It doesn't have to be the same attribute name, but should be same domain or type comparable. Okay, that is also important when we learn the SQL. SQL requires such a type comparable. Okay, so minus, we can do that. Then there are some property used in the set theory. For example, definitely intersection is a commutative. You can switch the order. Okay, so you learn this one. Obviously, this one is not true, so we cannot switch the order. It's not, minus is not type comparability. Then the Cartesian product. So Cartesian product is a very important operation in relational model. The reason is that if you remind what is the main idea of the conceptual modeling, ER modeling. So how did you do the ER modeling, conceptual modeling? You group by same entity. Student is here, and instructor is here. But sometimes we want to access the data, both student and instructor. But using unary operation, no way. We have seen here, employee and the department, no way to access two different relations. Even but intersection, the union, and minus, these operations, even though they are binary, they should be type comparable. Same the format of data. So no way to combine two different data sources, two different relations. However, this Cartesian product is just combine two relations. So for example, when you the Cartesian product R and S, attribute of R plus attribute of S, right? So as we have seen here, the example, the A1, A2, like that. So this one is from A, this one is from B. Cartesian product, all attribute, plus 1, all combination of the data. So eventually, instructor and student, we can combine together. So R times S, actually not time, product of S is the attribute of R plus attribute of S. What about number of tuples? So for example, when you A product B, A is a 10 element, B is a 5. What is the output? A product of B. How many tuples can be generated? 10, 5.
50.
15 or 50? 5, 0 or 1, 5? It's a 5, 0. Because it's all combination. 10 times 5. So that is the reason how many tuple? So number of tuple on R, number of tuple on S. The R times S is the total number of tuple by what? Cartesian product. Because of that, later you should be very careful when you are doing Cartesian product. If we are doing Cartesian product, it generates huge amount of data. For example, I have 1 million of data, table A. So another 1 million of data, B. 1 million is not that big nowadays. You can have easily millions of data in one table. Millions of data, one table. But if you Cartesian product, A and B, how many? Million times of million. Your memory will be exploded. That happen, easily happen in the SQL. We will see it later. So that is a Cartesian product. So that is called sometimes the closed product. So let's see this example. So we have data. One is employee, another one is this is not a good example. Later we will see. So such a Cartesian product. Okay? So this is the example of the Cartesian product between the female employee and the employee name. If you Cartesian product, it will be just the how many tuple are the attribute, all tuple of this one and all tuple of this. Then you can mark the cross product, all the cases. It will be like this. Okay? So you can see the first name, middle initial, last name. First name, middle name. This one is employee, the female, first name, last name, social security. First name, last name, social security. These three, the attribute is from this one. Okay, and not this one. And the other, the tuple from here is from the female underbar depend, female underscore the employee. Okay, so total is so all combination. Okay? So this is a Cartesian product. Then finally join operation. Okay. So we have the Cartesian product here. We will use the same, the first example. So first name and last name of employee, who work for research department. Okay? So who work for the research department? So always, when you build the relational algebra expression, find the source of data. In other words, a relation. So we have employee relation. So you can get the most of the information from the employee, but the research is not in the employee. It's the name of department is from the department. So there are two relations. One is employee, another one is department. This one has the department, the research, then eventually find their department number. Then from the department number, you need to check whose department number is 5. So using only this operation, can you build a relational algebra expression? Because they are separate, we cannot use the unary operation. First, we need to combine. How to combine? Right? So we can do the employee Cartesian product department. First, quick question. Employee, when you are doing the Cartesian product, does it need the type comparability or not? Type comparable or not?
Yes.
Yes? No. It doesn't need it, because this one and this one just combine. No matter how many attributes. For example, employee has the first name, last name, and SSN, and the DNO, salary, and the department has the DNO, D number, and D name, manager social security number, like that. You can just combine into one. It doesn't matter how many, what is the attribute of each, just combine. Okay, so this is a Cartesian product. Okay, what about the tuple? So let's say that we have the 10 employees. Let's say that we have the 5 departments. How many? When you Cartesian product, how many tuples will be generated? 50. So for each employee 5 times the department. For each employee 5 times. Total how many? 50 tuples will be generated as the output. However, we don't need all of them, right? What is the condition? Selection. What? We need to check research. So D name is the research. So only research department. So research department will be like that. Also, only the research department, their D number should be same as what?
D number in
The DNO in employee, right? We want to only employee whose DNO is 5, right? So which means one more selection. DNO in employee should be same as the D number. Okay? Then that is the employee who work for research department. Then if you wanna put the first name and last name, this is the final result. So this is the output. It's not fancy. Right? Yes, question.
Would it be possible for the select to have the two conditions
The same
on-
time? Yes.
Yeah.
So this question is, can we? Yes, you can do.
Or that is to do the same?
Yes. Still, it's not like the fancy, but this is the way to access the data from two different sources. Yes.
So do you have any queries like if the first name of the employee starts with some letter?
First name of employee. So can we apply the first name at the beginning?
No.
No?
First name of the employee starts with the employees with the starting letter as A.
So the first name starting with the A like that.
Yeah.
That will be the detailed operation. We will cover is a relational algebra. We do not have such operation, but later sequence we have such an operation. His question is like I'd like to retrieve all employees starting with the A.
Yeah.
Lee or lion or the such. So we will do the such the string operation in later. Answer is like. So we will use like operation in the SQL, not in relational algebra. Okay. So this is the relational algebra expression to access this data. However, this one is the Cartesian product provide the combination between two tables, two relations. However, the main problem of the Cartesian product is to generate all combination. Think about so. In my hometown, South Korea, the military service is not optional; it's compulsory. So when I was the age to join the army, it's the 18, but it can be waived until the college graduation. So I joined the army the 91. That's almost, I forgot the time, the year. 91. It's 2.5 years, 30 months. Actually, I waived a couple of months, so 28 months. So almost the 2.5 years. I should stay in the camp. It's not commute, so only the 30 days, the total, the vacation during the time. I came out of the military camp. I should stay inside. But from time to time, they allow the visiting from the family or friend. So especially the first the visiting is very popular. It's like the celebration after I finished the training camp. It's 6 weeks. It's very tough. So no interview, no meeting are allowed. But after we complete the first training camp, so then they allow the 1 night the vacation with the family. So actually, for this kind of tradition, all the cohort stay the one room and the family stay the other room. So if it's almost 2,000, 3,000 members, they find almost 10,000 family. It's really messed up when they open each other. So in the big the huge area, so it's really messed up to find the area. So what is the best way to find the family? So we know the name of the person or ID. So first check the ID of the soldier, then ask any family who's the son. Only the son, the man is required for the military service. Not woman. It's not like Israel. So Israel is the old, both the male and female, but in my hometown only the male. So your son's name or ID, so check the lead. Then we can match. So using the name, we can match the two groups. Otherwise, if we allow the Cartesian product, it's almost too many cases. So we can use what? D NO and D number. So this is kind of a clue to connect. This is all combination, but some of them are not required, right? What we need is only employee whose department name is research. Clue is D NO is equal to D number. This is a clue. So in this case, this is a clue. When you find your son from such a military camp, your son's name is the clue, right? Then we don't have to mess up. We don't have to be messed up in such a case. So can we combine this selection and this Cartesian product into one? Because we need both of them together whenever we combine these two. So this is called this joint operation. So if we use both selection with the Cartesian product, the next operation is the joint operation. So joint operation need for example, employee and the department. This is a Cartesian product. But Cartesian product with what? Condition, clue. In this case, D NO in employee should be same as D number in department. Then at that time to differentiate from the Cartesian product, we use this symbol. So then this is a join condition. So we can put the condition over here R and S like this. Any specific name of this symbol? I don't think nobody use except the database. This is kind of I usually call the ribbon. So my daughter, she has such a butterfly like the ribbon. So, but whatever the name is, this is the symbol for the one of the most popular signature operation in relational database. So this is called the join operation. So join operation is exactly same as what? Cartesian product plus selection. Cartesian product plus selection. But so instead of using the two operation, we can simplify with one. So this is called the join operation. So join operation is one of the most popular, the way, one of the signature. Because of the join operation, actually the SQL is very popular. Whenever you find the data, just join, right? Then when you join, you need to find the what? Join condition. If you have the join condition, then you can get the data that you want. The problem is how can we find the join condition?
Common attributes.
Common attribute. That is one way. But sometimes I can put just a name, but last name, it maybe looks like the different. So from the name, it's not always, we cannot guarantee, right? ESSN, SSN. Instead, we have foreign key.
Yeah.
Do you remember what is a foreign key? So foreign key is the condition, constraint of the relational database model. If two relations are related, we should have the foreign key. Like for example, D NO in employee should have this D NO should exist the department D number, right? So then we can create such a foreign key constraint. So foreign key is the clue. Later we can use such a same common name. But if we have the foreign key, we can use a foreign. That makes sense. If that doesn't exist in other relation, we cannot connect, right? We cannot condition. So most of the time, we can use the foreign key as a constraint. So go back to here. Can we make this request as a relational algebra expression? We can use employee and department. Employee and department. Then we need to find what? Join condition. Join condition is the foreign key is between the employee and department is DNO is equal to D number. Join condition. Then name is what? The name is research. Then first name, this is the selection. Then first name and last name. This is a result. So we can create the relational algebra expression using the join operation. So join operation is the most popular way to connect the multiple the relation. Most of SQL later, you need to access multiple the table, two or more table. At that time, you can use the join. Okay, so this is the join operation. There are several important characteristics of the join operation. So, for example, when you access the employee and department, you need to join with the join condition. Sometimes, let's say the department has DNO and this one has also DNO. How can you differentiate the same name? You can use dot notation. Dot notation is relation name dot attribute. So employee dot DNO is equal to department dot DNO. In case the same name, you can use such a dot notation. Relation dot attribute. This is a very popular. This is also used in the SQL later. So this is the one thing. Another thing. What if switch the order? Departments join with the employee. Any difference, or are they same? So for example, when you try to find your friend during the after military training camp. So first ask the military, find your family. Or first ask family, find your son. Eventually it's the same, right? So results are same. So it's you can switch. Okay, it doesn't matter. However, later performance will be different. Performance. Extreme case, we have one family visit, but we have 1,000 the military, the soldier. Okay, so we'd like to join. First, ask the each and every military, the soldier, whether this family is yours or not. How many times? 1,000 times you need to ask. But you have only one family visit. Ask the family, find your son. How many times? Only one time. Right? So performance will be different. So later, when we talk about query optimization, so query optimization, try to find efficient way. Which way is the best? So in terms of output, order is not critical. However, in terms of performance, join order is also very important. Okay, so this is a join operation. So join operation will be used a lot in your project and practice. So there are different types of join. Variation of join. First one is natural join. Natural join is represented by the R asterisk S. There is no join condition. Because natural join is what exactly you mentioned. When we join the two tables, join condition will be same name, common name. Okay? Naturally join with the common name. So we don't have to mention the specific the join condition automatically. However, we cannot guarantee that is the what we want or not. Okay? So naturally, if you use the same name of attribute for each relation, like the SSN is always SSN, every the table. Okay? DNO is DNO everywhere. At that time, you can use natural join, naturally join, which is not used a lot. In practical database, we don't use natural join. There is a big equijoin. Equijoin is the join of two relations with what? Equality join condition. Most popular. Right? So like the DNO is equal to D number. So equijoin. Okay. And the what else? ESSN is equal to SSN. Equality join. So equijoin is the most popular one. There is another one, theta join. Theta join is join two tables with inequality. Okay, for example, ES, the DNO is bigger than D number. Okay,
Not equal.
yeah, not equal. So theta join is possible also, but you should be careful. It will not be exactly what you want. Sometimes it can be more than you expect. So theta join also possible. But as you can see, due to the nature, equijoin is the most popular one. Okay, so this is the join. Couple of more things. So let's say that we have the R and S, the table, and attribute 1, attribute 2, and A3, A4. So it's an attribute name. So let's say the 1, 2, A, B. Then this A2 refer to this one. So B is the 2 and C is, I should use A. Okay, there are two tables, R and S. A2 refer the A3. Then this one is a primary key and primary key, like this. Then when we join R and S, for example, R, S, that is S, natural join. To be natural join, this name should be A2. Then we can join two tables. Then output of this one will be what? R and S. A1, A2, A2, A3, A4. Then A is matched and the B is matched. So 1, 2, A, 10, 2, B, 20. Like this. So this is the output. However, if we have the different name like that, so we cannot use natural join. Instead, we can use the condition A2 is equal to A3. So if we find A2 is equal to A3, only two of them are matched. So it will be like this. So this is the output of this. However, your manager asks, I need all the data of S. If matched, show. If not matched, just put the null. Because I want to see the A, B, C, all of them. Their result. But here, if you join the two tables with the join condition, only A, B, C is not here. Right? So, if you want to see the, for example, like this, A, B, C, and there's no match data, none. None. Like this. Sometimes you want to see, like for example, this is employee, this is your performance. Sometimes you do not. You have vacation last week, so you do not have any performance. So you will be eliminated because there is no match. If you want to keep such a match data, then you can keep, but it's not. At that time, you can use. This is called the outer join. Outer join. So there's a join over here. The join, outer join. So outer join is first write outer join. So right outer join means keep all the data on right hand side. Okay? If match it, you can return the matched one. If there's no matched one, and put the null. Okay? So this is called the outer join. So for example, you have employee. So I'd like to see the performance of year. But if you do not have any performance, it's no data, you will be eliminated from the join table. So, but I'd like to see whether null or something. So at that time you can use outer join. So outer join is useful to keep the non-matched data. So at that time we can use a symbol like this, right hand side. Cover include this side, right hand side. It's a right outer join. Right outer join. Like this. Similarly, if we have like the D, but it's not matched, I want to keep the left hand side, which means this will be the 3D null, null, like this. Keep the left hand side. Then we can use this one, left hand side. This is called the left outer join. This is a left outer join. Okay? And what about the both sides? I'd like to keep the this and also this. So for example, null, null, and the C, and this is 30, like this. At the time, we can use a full outer join. Then symbol is like this, both sides. You can open both sides. It's a full outer join. So this is the final output of the full outer join. So outer join has a variation, left outer join, right outer join, full outer join. First, left and right outer join are almost the same. You can just switch the order of this one, right? Full outer join doesn't make sense sometimes. For example, if this one is left for this, doesn't exist, doesn't make sense. Okay? So full outer join can be used only very limited special case. So it's not fully used actually in real application. Left outer join is the most popular one. So in SQL later, if you learn, when we practice the SQL, so the left outer join is the most popular. In case you need the right outer join, you can switch the order. Okay? Full outer join is also possible, but not frequent, is popularly used. So this is the left outer join, right outer join, full outer join. So we will see the example later. So that is the outer join. One more. The aggregate function. Aggregation. Okay, function. So this is a requirement. From each department, I'd like to know average salary, not average salary, the number of employees for each department. You need to count, right? How can you count? So I'm going to use two methods. So CS1 and the E1 and CS2 and the ME, I need another hand like that. This is better. Or second method is line up by the department. So CS is first, C is first, CS, then ME and technical management. Then count from the beginning for the CS. Then the C, then the TM. Which method is better? A or B? First method or second method when you count? B is later is better, right? So sometimes we need to count by the group. Not only count, average. Average salary by department. Also, highest salary per department. So we need to do the grouping first, right? Then apply one, which is called the aggregate function. Aggregate function require grouping cluster first. Then most of one statistical function. So any example of such a statistical function, aggregate function? Count. Median. Median is slightly different, but we consider. Because the median is not actually statistical function. It's order and just in the middle. It takes a longer time to calculate. But the median also draw by group. Mean, average, minimum, maximum, variation. You remember the variation? Right? It's how much far from the middle, average. Standard deviation. Right? Any other? Such a function. These are the popular statistical function, also is called the aggregate function. Aggregate function means first you need to group. Group 1, group 2, and grouping. Then apply minimum, maximum, count, and such a minimum, maximum, count. Minimum, maximum, count. So we try to apply the such aggregate function for our relational algebra operation. So I'd like to count number of employed by department. So output is like this: department number and number of employed. 1, 10, 2, 20, 3, 15, 4, 2, like this. This is what we expect as the output. Can you do using this one? There's no way for grouping. So we need to consider another relational algebra operation for grouping. So by group, this is a group. So at that time we can use aggregate function. It's not good. I think there is a kind of Greek letter. I'm not sure. It's F, capital letter of F function. Then left hand side is the grouping factor. Right hand side is the aggregate function. So for example, this one. So here, always you need to decide what? Source of your data, employed. So this is a relation. For example, employed. For the employed, it's a group by what? Department, DNO. Okay? Then it's a count. So we can count what?
Department.
How do you know the number of employees? Should it be unique or it can be duplicated? If you count name, it may be Patel. Instead, we can use SSA. Primary key is better.
Employee.
Okay, or employee ID such as ID. The key is counted. So this is the output of this region. So we can use the aggregate function. So whenever you use the aggregate function, you need to decide the grouping factor. First grouping, then apply what? Count or aggregate function. One other, the last one. I'd like to return department number whose employee is bigger than 2. Similar, but I need only whose employee is bigger than 2. How can you do that? We can use this one, but after this, selection count is bigger than 2. true. You need to apply the condition, selection condition after aggregate function. You cannot apply this one in advance. Okay? It's always important whenever you use aggregate function, always such a condition of the group will be after aggregation, after grouping. That is very important in SQL later. Okay, we will see. So this is an aggregate function. So in 5 minutes, what other example of such an aggregate function? Minimum, maximum, standard deviation, STD, and the variation, and the mean, the average, and count. Sometimes median, but median is slightly different. But median can be considered. Some of them implement the median, sometimes why? It takes a long time. So median actually is not, it's as simple as a concept, but not simple when you implement. So this is the possible aggregate function. Okay, then, in 5 minutes, I'd like to explain the SQL syntax. What is the most popular? Anyone who ever used the SQL language before? The very well-known syntax of the SQL, what is that? Select. So you heard about even the select. So select
Start.
from, right? Name of what? Attribute. Name of relation table. Where is the condition? This is really well-known syntax of the SQL. Because of that, it is very popular, still being used. Even non-relational database management system use this kind of select from where. It's a very intuitive, and everybody can understand the meaning of that. So let's see. Selection. This condition is what? Selection condition. Okay? You can put such a selection condition in where? What about this? Project. Project is a list of attributes. So list of attributes is here. Project. Then rename of the relation. Rename. You can alias. Rename of table name as. So alias is called the alias. So like the EMP as E, like that. And the rename of attribute. You can rename of attribute. Also as alias of attribute. You can rename. Then what about this one? You can use minus, union, and the intersection with another select from where? Like this. Then join. Join is join condition. So there are two types of condition. One is join condition. Another one is selection condition in where clause. What about the Cartesian product? Cartesian product, you don't have to do anything, just without condition. It is Cartesian product. Or join condition. So look for the join. Equijoin, theta join is depending on the where. And right outer join, left outer join, full outer join, you can put the left outer join here. Left outer join. Then aggregate function is a group by. Group by and grouping factor. Dn is going to here. Grouping factor. Then what about this function? Will be aggregate function. Will be with attribute. So as you can see, all relational algebra operation and expression are implemented in SQL. So if you understand the relational algebra expression, you can create the SQL easily. So next class, we are going to start the SQL practice. While you are practicing, the DBR will explain the syntax of the SQL. There are several things more to complete the relational algebra expression. We will complete beginning of next class, but I will spend 10 to 20 minutes on it. Then if we need the time, the next week Monday we will continue that part. Any questions? I will give the more practice, but the most important part is while you are doing the practice on GCP for your MySQL database, time practice. Okay. At that time, think about the relational algebra expression. Then it will be really helpful later when you build your own SQL. Okay. So next class, please bring your laptop. Your MySQL should be running. You should be able to connect the internet and the GCP console. Any questions? Okay, thank you. Today I forgot to bring the